All right, boys and girls, welcome back to the drive-through. Special shout out to time. And since we don't have a lot, we're going to move on. This lesson is about spheres, volume, surface area, and relationships. All right, let's get on with it. Spheres, three-dimensional circles, made up of lots of circles. I mean, infinitely many circles. Okay? The only measurement of a sphere, well, I shouldn't say the only, the two measurements of a sphere that matter are radius and diameter. I could have drawn my diameter inside of the sphere, but I thought it would get kind of confusing. Okay? So, first let's just get to the nitty-gritty. What is the surface area of a sphere? It is 4 pi r squared. That always amazes me. That means if you took a basketball and you cut out a circle that was a two-dimensional representation of the size of that basketball, and then you copied that thing a total of 4 times, you could paste that all around the extra basketball and you would have no extras. That's what that means. Okay? The volume of a sphere is 4/3 times pi times r cubed. So just remember, the volume goes with cubes. The surface area goes with squares. Okay? Alright, so that's like 2/3 of the lesson down. And now all you need to know, and this is for all similar shapes, but we talk about it with spheres, okay? If two figures are similar, and three-dimensional, the relationships between scale are as follows. Okay? So let's say that the scale factor was A to B. Okay? Well then, hopefully you remember that the surface area scale will be A squared to B squared. Okay? And maybe it's sensible to you that the volume scale will be A cubed to B cubed. So let's do an example. How much more volume does a volleyball have than a baseball if the volleyball has a radius that is 4 times bigger. Sorry that I'm writing all this out, being lazy. Okay, so look, the ratio between a baseball to a volleyball is 1:4. Okay? So, I'll just write out the work. What is the volume? Well, the volume of the baseball is 4/3 times pi times x cubed, where x is the radius, so we'll just call it r. Okay? The volume of the volleyball is 4/3 times pi. Well, now this r is 4r cubed, which is equal to 4/3 times pi times, let's see, 4 times 4 is 16, times 4 is 64. So look at this. Compare this one to that one, and you'll see that the bottom one, the volleyball, is exactly 64 times bigger than the baseball. And that completely supports this fact from this. Okay? So, since the scale factor is 1 to 4, the volume factor would be 1 cubed to 4 cubed, which is 1 to 64. And indeed, a volleyball has about 64 times more space than a baseball, which means you could fit about 64 baseballs if you could melt them down and put them inside of a volleyball. That's how many you could fit in. Amazing. Hope this helps. Boom!